So these analyzing graph questions are similar to the question that you had at the end of your derivative test. This one, the equation is given, but what we can do is we can figure this out. We can figure this out even if this equation wasn't given and we weren't given any numbers. So we can imagine no numbers were given, because sometimes when the numbers are given, you're able to do this without having to think about the graph. So what we're going to do with this analyzing graph section, we're going to ignore all the numbers and just say we started with the parabola. And we're told that this is the graph of f. So could we sketch the graphs of f prime, and could we sketch the graphs of f double prime if we weren't given any values? Because if you're actually given this equation here, all you would do is take the derivative, you'd get negative 2x minus 2, and you would graph that line, and it would be super easy because it's y equals mx plus b. And then you'd take the second derivative and get negative 2, and you would graph that line, that horizontal line, because it's really easy because you have those values. But the question is, can we still do that if we don't have any equations given? We're just given a parabola like this. What do we know? What do we know about the derivative? Well, we know that the derivative is equal to 0 right here. But we don't know what that value is. All we know that it's one ticky mark over. So I'm going to graph the derivative in red. And because I know that I have a local maximum at that point, I can go down to here and I say, I know that my function, my derivative, has to equal 0 at that point. And I don't know what that point is, but I can mark it on my first derivative test right there. What do I know from my first derivative test? Which way will my arrows go on my first derivative test? Will this arrow be like this or like that? It will be up. How do we know it's up? Because our function is increasing. This part from left to right is going up until it hits that. So we know that our derivative has to be positive in that section. And what do we know after that section? It's going down. So our derivative has to be negative in that section. Now, we also see that this most likely is a parabola. We saw from the equation that it was. If this was a parabola, that means our derivative will be a line. And we need our values to be positive here and negative after. So this is a possibility for our graph. I don't know how accurate that is with its slope. It might have been a little bit different. Maybe its slope was steeper. But for right now, without values, that's the best that I can do. If we had a straight line and we did our second derivative test, can you see that our straight line has no maximums and no minimums? There's going to be no places that our second derivative is going to equal 0. Can you see from this red line that the slope of that red line is always negative? So for our second derivative, we'll always have it concave down. Could you see that you could say that it's always concave down by looking at our original function as well? We have a parabola that's always concave down. So what do we know about our second derivative? It's always negative. And it's going to be always negative according to whatever slope that we have here. According to what I've drawn a rise of 1 and a run of negative 2. Can you see that for my slope of my red line? That it has a slope of negative 1/2. So as far as graphing my second derivative, which I'll do in purple, according to what I drew first, my second derivative would be negative 1/2. So now we can see, based on the equation that was given to us, my drawing is a little bit off, because the equation that was given to us, our second derivative would have been negative 2. But my drawing, I came up with negative 1/2. But when you're given these questions of just analyzing the graphs, they're not going to be too particular in whether you were perfect. But the important things here, your first derivative's got to be a line that's decreasing. Your second derivative would have to be flat. So there's our first sentence, our first set of analyzing graphs. For our second one here, it looks identical, except now they're told that this original blue graph is actually the graph of f prime of x. Again, we're going to ignore all of these numbers along here. And just try to imagine what's happening. So now we're told this one is the derivative. So what do we know about our derivative? And how does that help us find our functions that were before that and after that? Well, if this is our derivative, we know our first derivative test, we know that it's equal to 0 here and here. If the first derivative is equal to 0, what does that tell us about our function? That we either have maximums or minimums or inflection points at those values. From this graph, I can tell this first section whether it's going to be positive or negative. What is it going to be looking at that graph? It's going to be negative. Okay? Again, we have to think back. How did we figure out? So whenever we're doing this, now we have to think back. What did we do when we did our first derivative test? We plugged a value into our derivative to find out whether it was positive or negative. If this is my derivative graph, when I plug in a value in this section, which is this section right here, can you see that no matter what I plug in, I'm always going to hit a negative y value? That's why this section is negative. And if that section is negative, what does it tell us about our original graph? It tells us that our original graph has to be decreasing. In this middle section between these two x-intercepts, any value that I plug in there, my y values are going to be positive. So I would know that this section on my actual graph is increasing. And finally, this last section will be negative as well. So I know my original graph has to be decreasing, then increasing, then decreasing. So I know this is a local min, and this is a local max. All right, we'll continue with this one next class.